All right, so I am sharing my screen. Let's get this thing started. Oh, I need to turn the projector on. There we go. Okay, we need to start on chapter 13. No, slide 13.
I like calendar.
Yeah,
It's one of my favorite editions. Calendars.
Okay. We left off, and we're about to talk about algorithms. Okay. Now, is the lights? I mean, y'all can see that from the back. Everything. Okay. So, if you want a computer performance test, just start by writing an algorithm. We talked a little bit about that last time, but it's really a sequence of instructions. You're going to do this and this and this and this and that. Okay. It's like a recipe. It's a set of instructions written in sequence. Okay. But unlike a recipe, it's kind of, you've got to be very precise in what you do. A student submitted an algorithm to me yesterday, and I looked at it. He said, if it's 5 a.m., turn off the alarm. Else, hit snooze. So is there a problem with that? So again, if it's 5 a.m., turn off the alarm. Else, hit snooze.
You never really start the alarm?
Well, I'm assuming it's already started. That was his thing to get up.
Does it ever turn it back on?
Well, he doesn't turn it back on, but
Does it ever turn it off?
what I was thinking is, okay, so if it's 5 a.m., he's going to turn it off. But,
You can't hit snooze.
I mean, yeah, there's no snooze option for 5 a.m. And what if he has a 6 a.m. alarm? So basically, everything other than 5, he hits snooze. So I was like, so what happens if you have a different alarm other than 5? You're always going to hit snooze. You're never going to turn it off. You see what I'm saying? You're going to continually snooze it. And it really wasn't in a loop. So it was, you know, it wasn't clear enough. Yeah, but it's fine. You know, that was in my beginning Java class. So that's what they're supposed to do. And I'm going to give them comments on that. But when writing algorithms, you have to be very precise. Perfect example of me recently. I've been making a cauliflower crusted pizza. I don't know if you ever had that, but it's a low carb option and it's amazing. I make it in my house and everybody devours it. They had the option of getting a different pizza and they didn't want it. They wanted this one. So, but when you make it, you basically grind up the cauliflower, then you cook it for like 4 minutes. But then you got to get the water out of it. The instructions didn't explain how to get the water out of it. So first time I did it, I kind of put some towels down, and was trying to smush all the water out of it. Because it really didn't say. It just says use towel, get water out of cauliflower. How would you do that? Was that instruction clear enough of how to get the water out? No, then once I finally found a video, what they did is they put the cauliflower in the middle of the towel, wrapped it around it, and then just twisted it so it's, you know, get the water out. So I'm like, oh, the instructions were clear. I could have done that without having to find a darn video. Okay, because I had never done that before. All right, so it says, with complex problems, software developers write an algorithm before they attempt to write a computer program. Okay, I wrote way back before Campus and D2L, WebCT, and all them. I wrote our very first learning management system that we use here at Rose State College. You could check your grades and you could take quizzes. That's about all you could do with it. But we had nothing, so that was amazing. And everybody, absolutely, I mean, even Park University was using my darn program. But I just wrote it. Okay, I didn't design it, I just wrote it. Well, there was issues in it. So then I rewrote it a second time. Well, there was still more issues in it. So the third time I said, you know what, I'm actually gonna sit down and think about this and design it correctly, and it works so much better. So the point is, just writing code a lot of times works fine. But if you're writing complex code, yeah, you probably need to design it a little bit. Can you imagine writing the software that controls SpaceX's rockets? It's all run by software. There's not a single person in the rocket. Can you imagine not designing that correctly? And whoops, that number was off. And I was actually reading the book on that, and they were saying that their Falcon 1 rocket, the second launch attempt, actually got up into space, but when it separated, they hit each other. The part separating and the other part that was going to take off hit. So the way they fit, and it obviously crashed. So with the next launch, they changed one number in the entire code just to increase the delay between the rocket firing. That's what's it. They literally changed one number in the piece of code to do it's like one number was off and caused that for an entire rocket to crash. But, obviously they design them well because they work now. Can you imagine if they didn't? I would definitely not want to fly on one. That would be some scary stuff, okay? For this class, we will always write an algorithm for each project. That's what it says. I'm not saying everyone could do it every single time, but it's a good idea to get into the habit of it, especially more complex programs. I grade assignments all the time, and it never fails. Somebody writes the entire program and then tries to run it. And it's got, 82 errors. And it's like, we're going to see how that works when we do it. But developing problem-solving skills is kind of important, okay? And you will see some test questions on your exams. Hey, what's wrong with this code? So you have to be able to figure out what's wrong with it. Kind of important, okay? Okay, they need to be unambiguous. In other words, very precise. You come to class in room BS 218, Mondays and Wednesdays at 12:30 from August 20th until December 12th, with the exception of this. Okay, that's pretty precise, okay? If I just said, come to class Monday, Wednesday at 12:30, then you probably wouldn't, but you could show up on Thanksgiving week, and I'm not going to be here. I don't know about you guys. So you need something that's unambiguous. Needs to be executable, needs to do something. I get some people that write programs, I'm like, your program does nothing. I mean, yes, it compiles and runs, but it does nothing. So, why do that? And it also needs to end. If you have something that keeps running forever, it's not a good thing either. Years ago, that last bullet there was a really big deal because our computers didn't have as much memory, they didn't have as much power. When something ran, it pretty much took over all the resources. Then if it didn't stop, your computer was totally locked up and you had to turn your machine off. Nowadays, you do Control-C and you can quit it, no problem. But I used to do an exercise with students in my networking class, or my hardware class, where I would have them bring up a pinball. Y'all remember pinball in Windows? Well, if you would set pinball to use maximum resources available, the computer dies. I mean, it was literally 100% of your resources was going to the pinball game. You couldn't even use the keyboard. You couldn't use the mouse. You couldn't do nothing. It was literally the game running that you couldn't interact with. So I don't even know why that option was available, okay? But yeah, terminating, kind of a big deal, okay? All right, so algorithms are simple plans. We talked about that. You already know quite a few. I mean, they calculate, y'all know what like geometry is and all that stuff in algebra. Do you ever use that stuff in real life? Yeah. You do, you just don't realize it. I had to calculate the length of a strap to go around my hot tub. I'm like, wait a minute, pi r squared is compass of a circle. And it actually worked. I'm like, amazing. And actually, there is use for these things in line. But yeah, we do. I mean, you might not remember all of them, but there's already quite a few algorithms you use, okay? So some problems are more complex, obviously. If you're going to calculate pi, that would be a little bit, or calculate a missile trajectory, that would be a little bit tougher as well, okay? Simple example, it says you get to drink, now I erased orange juice, if you don't, you're going to drink water. Y'all agree? She's got water. Drink. You drink water. Okay. So, simple algorithm. You have a clean glass from the cabinet. You have water in your refrigerator. Okay, that's what we have. So that's the two things we have. So, one valid is get a glass from the cabinet, go to the refrigerator, get the water container, open the container, pour the water from the container into the glass, put the water back into the refrigerator, and drink your water. So is that a good algorithm, you think? Could you get a glass of water based upon that? We could. But are there some things that are not quite clear?
Yes, you don't close the refrigerator.
Don't close the fridge. That's my mother-in-law's problem. She'll get something out and go to her room. I'll come home. Why is the fridge wide open? Oh, I didn't do it.
Close the container when you're done.
Look at number 4. Pour water from the container into the glass. When do you stop? You can literally just keep pouring forever. Do you agree? The glass might be full, but you can still keep pouring. Okay? All right. And what if you don't want to drink the whole glass of water? So, I mean, there's a few things that could be better, but this is a basic one. It's not bad. How about selecting a car? You have a choice of buying 2 cars. One is a more fuel efficient than the other, but also more expensive. Okay, I run a Chevy Volt, which I love, but yes, it's more expensive than other cars because it's an efficient car. Okay, it says you know the price of fuel efficiency in miles per gallon of each car. You plan to keep the car for 10 years. Which car would be a better deal based on money? What do you think? Without going any farther, what do you think? So would you buy the cheaper car, which is not quite as efficient, or would you buy the more expensive car that's more efficient?
Expensive car that's more efficient.
It's an expensive car. I would assume based on 10 years, I would be saving money doing
It
that.
doesn't give you any details on the second car.
Right. It really doesn't give us enough. We don't know the MPG they're getting. We don't even know the cost at this point. But, you know, it's kind of like my house. I have solar panels on my house. I have 41 solar panels. 10, 15-year payback, possibly. But the cool thing is I got them a couple of years ago, and I paid the bill then. So now, at least in all the winter months, I literally have no electricity. So as electricity rates rise, I don't care. So, it makes you wonder. Okay. So inputs and outputs from the problem set, we know that car 1, we know the purchase price and the efficiency. We know the purchase price and efficiency of car 2. Gas costs $4 a gallon. We got 15,000 miles in 10 years. So now at least we're getting a little bit more data. We still don't have a lot of data, but we're getting a little bit more information to help us figure this out. So for each car, we need to calculate the annual fuel consumed for each car. And based upon efficiency and the miles, we should be able to do that. You all agree? Should be able to. Okay, the annual fuel cost for the car, operating cost for the car, total cost of each car, and then we calculate to see which one's lowest. Okay. All right, we got to figure out the total cost. To calculate the total cost of each car, we need to calculate the operating cost. The operating cost depends on the annual fuel cost. In other words, what does the cost to put gas in this car for an entire year? The cost is the gallons, or price per gallon, times the amount you consume. Okay? Obviously, the more efficient will use less gas. The annual fuel consumed is the annual miles driven divided by the fuel efficiency, which we don't know yet, do we? We still do not know the efficiency. Okay. Describe each subtask as pseudocode. Okay. I'm not going to make you write all these down because they're already in here. But, so the total cost is the purchase price plus the operating cost. So let's look at these. All right. So if we have annual fuel consumed would be the miles driven divided by fuel efficiency. Does everybody understand that? Makes sense? So in other words, the miles per gallon, divide total driven by the miles per gallon. Okay. Then the fuel cost is price per gallon times how much we used. The more efficient car would use less gas. So the operating cost is length of time times the annual cost. Then the total cost is the purchase price plus the operating cost. Okay. So if car 1 is cheaper, we choose car 1. If else, we choose car 2. So that would, does that make sense? Would that work if we knew the efficiency and all that? Can we do that? Yeah. I don't think they actually have the code in here for that, but they don't have the code. Maybe one of these days I'll make y'all do that because it's not a bad one, but we could do it for my car. Okay. Anyone drive a fuel efficient car here?
I have a Nissan Sentra.
Nissan what?
Sentra.
Anyone drive a Ford Fusion? My ex-wife bought one, and literally, she bought it, and literally within the first week, they sent her a $400 gift card. You know why? Because they advertised a certain efficiency, but the car didn't get it. So they calculated the difference in what it actually got compared to the advertised amount over a length of time and gave her a gift card for that amount. That sucks.
Yeah.
I would be pissed. I'm like, what? Because yeah, you're gonna spend that $400 gift card this week. Now you're not gonna be getting your mileage the rest of the time. Okay, bank account. You can put money in a bank. I actually do a program with this one, but determine how much money you're gonna make based upon interest. So wouldn't be hard to do. Could y'all do this kind of stuff in Excel? Yeah, it wouldn't be hard. So you could do it very easily in here. We're gonna do some of this stuff. Okay. And I don't want to walk through all their steps. I want to get into actually doing something here in a second. There's the bank. Let's talk about Python. It came out in the 1990s. It was funny because initially, everyone said, why are you writing this program? No one's going to use it. Now it's like the most popular language out there. Okay? Same way with everything. Von Rosman was dissatisfied with the languages available, so he said they were all optimized for large programs, but we didn't want large programs. See, a big difference between Python and like Java. Java's compiled. Python is interpreted. You don't compile Python. You write it and run it, and it interprets the code while it runs and gives you the output. You don't have to compile it. See, the problem with compiling things are, say like you're running C++. You compile it for Windows, assume, okay? What's it gonna run on? Windows, that's it. With Python, it doesn't compile. So it's not made for Windows or for Mac or for Linux. It's Python, and each operating system handles their own interpretation of the code and the outputs, and they should be the same, okay? He needed a language that could not only be used for complete programs quickly, but could also be used to do things easy. And I talked about some different languages there. They're executed by the interpreter. They're not compiled. It says the interpreter reads your program, interprets the code, and then executes, assuming there's no errors. Okay. The nice thing about Python is sometimes it'll actually, run part of it, or at least, interpret part of it, and then you can very easily keep working your way down to the errors. Okay, there's different environments. We're going to be using idle in here. I know some of you are familiar with idle. There's also PyCharm. There's a whole bunch of different ones. And here they talk about wing. We're not going to use wing. You could if you want to. I don't really care. They're all about the same. But if you actually look at the book, it's funny. These slides were made for this book, and they don't use the same IDE. They're using something called Spring or something in the book. I forget what it is. It begins with S. Yet in the slides, they're using Wing. It's not the same one. We're going to use something totally different. Okay. The components of it. You can list your code. You can color the lines. Auto indenting features. All that's built into pretty much all of them. Okay. And they pretty much all have an output window, a debug window. And you can actually even run Python just at the command line. You can do that as well. Okay. This is what Wing looks like in the back. This is what Python looks like in the front. Okay. Yeah, that one's a little bit prettier, but for what we're going to do, this one's fine. You can also use PyCharm. PyCharm's good as well. The main reason I like idle, it works on Windows, it works on Mac, it works on Linux, it works on everything. Okay. PyCharm does not. Okay. Wing, I don't know. So we're going to be using idle. That's what it looks like there. Okay, for some reason I must have clicked something. Okay, the whole program in Python. Actually, let's do this. We need to do something in here. On your computers, I want you guys to, now you can click around, but if you just hit the Windows key, that key between the Control and the Alt, on Mac you can just do it up at the top. Just type idle, I-D-L-E, and it should immediately come up with your idle program. And it should look like, come on, there it is. Should look like that. Now there's a way to make this larger. Anyone remember how? Probably right here. Let's go, how about Lucidia console? Come on, where are you? Lucidia console. And let's go with, how about a 20? Okay, that a little better? All right. Y'all find this? I'm assuming everybody's finding it. If you're not finding it, say, hey, I'm not finding it. It's called idle, okay? Well, according to our slides, we're going to do exactly what the slides show right here. Type in exactly what you see there. My first, oops. My, can't spell. Okay, so what did that first line do? Anybody? Anything?
You commented.
It's really just a comment. That's all it is. Print. Hello. World. I can't spell. This keyword's too low. And then we need that and that. Now when I hit that, I should get hello world on the screen. Is everybody getting all this? Mm-hmm. Pretty simple stuff to do. The first one was a comment. The second one told it to do something. It said print hello world, and it printed it on the console. Okay. Now, comments. First of all, comments required. What do you think? I mean, for a program to run, are comments required? No, not at all. But when you write complicated programs, they get confusing.
It's easier for the person interpreting it
Right.
later.
Right, exactly. And, you know, I write programs all the time. Like, I teach digital forensics every spring. And I always write a new program each spring for something I'm doing in that class. And then the next spring, I go to modify it. I'm like, crap, what did I do last year? Because you don't think about it, but you don't remember this kind of stuff. Now, we actually wrote this right inside the command shell. This is inside of Python. That's probably not the best place to do it. Does anyone know why it's not a good place to do it? We can't save it. You can't save this anywhere. So let me show you how to do it in a place you can save it. You go File, New File. I know most of you have probably already done this, but I'm going to do it anyway. So we're going to create a new file. I'm going to put that code in there. I think I can actually copy those two right out of there. Put them right in there. Obviously, I'll have to get rid of the whole who's know what's is there.
I didn't realize you could actually type code in there.
You can type it right into it. And actually typing right in the interpreter is kind of nice. Like if I want to know what 5 plus 2 is, 7, done. Yeah, it's pretty nice. So if I want to say 7, actually, does this work in Python? Hold on, let's find out. 7 mod 2, yes it does. If I want to find out what 7 modulus 2 was, which we'll learn more about, it tells me that as well. So now I have my code inside my program. I'm going to save it. I don't care where you save it. I'm going to save mine. It always wants to save in the darn Python directory. Don't save it there. Save it somewhere else. I'm going to call it hello world.py. Okay. Now, I have my program written and saved. Up under run, I can hit F5 to run it. Now I can click F5 like that, and you'll see it restarted my command shell and it output hello world. I could have also just hit F5 control key and it would have done the same. Now, if I actually close out that interpreter window, it'll actually bring it back up for me. So it's kind of cool. So, and you'll see it does restart it every time. Get it so I can see both on the screen. All right. So if I was to make both of them smaller, this one up here. All right, we're going to do F5 a couple times, and you'll see it literally just keeps restarting it. Okay, easy enough. Everybody with me here? I know it's super basic, but you know, and what I need now. Does anyone have a computer at home you're going to work on with this stuff? Does anyone not have a computer at home? That's be an easier question. Okay, what you're going to do for your let's finish the chapter, but you're going to do an assignment in this week. Okay. Now, let's talk about a few things while we're here. Okay, typing in will be good practice. Be careful spelling. Oh, spelling is such a big deal. You know, print versus print. Okay. It is case sensitive, like most languages. Not all. Visual Basic's not case sensitive, but most of them are. So get used to the case sensitivity. Okay. Text editing, you can actually, writing a text editor, you can actually write it in Notepad even. I mean, you can write it in, you can even write it in Edlin or VI or whatever you feel like doing. Okay, so once saved, you can compile and run it. You're technically not compiling it, you're interpreting it because it does not compile it into object code or bytecode or anything. It literally just runs it, okay? So compile and execute, again, it really does not compile, but then it gives us output. Okay. And you can do it at the command prompt as well. Your source code is a py file, or I think pyw as well, but we're going to use py. So in here, we're going to create a file. You can put all of them in there, know where you store them. I store them on my desktop. It's just easier for me to find. And then back up your work to a network drive. You have Google Drive. If you want to work on stuff here and take it home, make sure you can do that. Because if you store it on the computer here and go home, you can't get to the computer here. So you might want to, I don't know if there's a place in Canvas to put files. There probably is. If not, you have Google Drive and everywhere else. Okay. Okay, the interactive mode says, like other programs, you can write, save, and complete Python programs in a file, but you can also do it interactive, just like I showed you. You can literally bring up the interpreter, which is the other one, this one here, and you can do stuff. You know, you can say like int num equals 5. Darn it, I can't do that? Yeah, I can. They didn't want me to specify a type. That's fine. So I said num is 5. So I can say num plus 2, and it gives me 7. Okay. So what that did there is I declared, why didn't I take the double? We'll figure it out. But I declared a variable called num, and I set it to the value of 5. Is this chair in the way for anybody? I would hate this chair. No, we're not. Won't get there. We'll stick it over here. I don't know. Fall on it, but. So I declared a variable equal to 5, and then I told the interpreter, take that variable, add 2 to it. Now what if I said something like a variable I had not declared yet? Num2 plus 2. What do you think will happen?
Yeah, error.
Should get an error. It says, what the heck? It says on line 1, which is what I was running right here, in this module, my Python shell number 3, and it's because I ran it 3 times. This right here, it says error, num2 is not defined. So it's telling me the line, the number, line 1. It's telling me what the code is, which is that same code there. And it's telling me num2 is not defined. So if you ever see something like that, whatever your variable name is, you didn't define it. In this case, I called it num. Down here, I try and call it num2, and there's no such variable. Okay? Easy enough there?
Yep.
Okay. So interactive modes, we can do that as well. Source code says the compiler reads the program and generates bytecode instructions, but it really doesn't save them out, but it really sends them to the Python virtual machine. It's a program that is similar to the CPU in your computer. It has all the libraries, and there's a bunch of libraries built in we're going to use, and we're going to learn how to add libraries. Anyone ever add libraries before? I use passlib. It's wonderful. Like for encryption and stuff like that, it's very handy. But we'll look at that. Okay, so we already opened up our compiler. And I don't use Wing, but you know, if you really want to use Wing, you can. The toolbars are about the same. There's not that much difference. Actually, let's look at idle for a second. The other one. Okay, inside here, let's go through a couple of the menu options in case you're not familiar. Under file, you can make a new file. You can open a file. You can open a module. You can see the recent stuff. You can clear it. You can save as. A lot of stuff you can do with it. Under edit, select, copy, paste, the normal stuff there. Find and replace. You might think, why would I want find and find? Well, what if you got this really long, multi-100-line program? Find stuff that way. Format. You can indent regions and dedent regions. Let me show you what that does. Let's go into my code right here and pretend I want to comment out this print line. Now I can literally just put a pound sign in front of it, or I could do comment out region. And notice it automatically puts comments in front of it. Or I can uncomment region and removes the comments. I mean, we're talking one line of code. But if you have a large section of code and you want to like bypass some, comment it out. Okay. Yeah. You have a question? Okay. And then you can also indent it. Python's real big on indenting. Real big on it. If you get that wrong, it ain't gonna work. So we will see that. So you can dedent. There's all kinds of little things you can do in here. Just play with it. And you can run it. You can do whatever. F5 to run it. That's what I normally do. Or you can just run it from the menu and configure. You can change your font like I did. That's about it in the editor. So it's kind of what we already did our program. Okay. It says, right. Oh, I didn't bring my book in. What the heck is, I think, hold on, I think that's, we're almost done. Let's finish this, then we're going to work on a program. Okay, we got time. Okay. Let me finish the slides and then we're going to work on something. Okay. Analyze our first program. The first program contains one or more lines. We know what that does. We know that we have a comment line. We know we have a line that prints as a string. Nothing, no big deal, just like they say. Okay. The print method is now, depending on which version of Python you're using, if you're using a version prior to version 3, you don't use the parentheses. If you're using 3 and above, which we are using, you use the parentheses. A lot of times when you find code online, it'll be written for like 2.7 or something. So you'll have to take it and modify it by adding like parentheses and different things like that. So that's a big change in it. Okay. All right. Syntax for Python programs. To use a call Python, you need to specify the name of the function, which we're going to do. Arguments. Now, I can't show the thing at the same time. This here, this print. Come on, get back up. Where's my mouse? There it is. So print right here is actually a function or a method that someone wrote. And we're passing hello world to it. That's called an argument. That is a string argument we're passing to the print method. Okay? Easy enough there. So a sequence of characters including quotes is known as a string. I just showed you that. And the cool thing about Python is you can actually use double quotes or the single quote, and it'll actually work the same for most things. There are a few differences which we'll talk about later, but they have to match. Say I use a single quote at the beginning, a double quote at the end, it ain't gonna like it. Nope. The error there was end of line while scanning string literal. So it found the beginning of my string and never found an ending one. The cool thing is, say I started with a single quote, then I could actually end it with a single quote. And now it's going to assume the double quote is actually a double quote.
You do not need to do it.
No, watch. Perfectly. Yeah, it's different in here. Now, what if I want to print a single quote? What you can do is you can go over here and put it in double quotes. Maybe you put your single quote inside your text. Now, if I do, it'll actually print out the single quote. It's a little different from like Java and all them. You actually have to use exception. You got to use the backslash, but here you don't have to. You do for some things, just not for this. Okay, so that's pretty handy. More examples. You can actually print out a value. This example here will actually print out a 7 because since it's inside of parentheses there, it will actually do the math and print it out. You can also do this. Now you'll notice here, they have the answer is. Let's write this part right here. Try to write that piece of code. We're going to change it up a little bit. Get back to this. No, it's not the one I want. I want that one. I'll move it so you can see it. One second. I want you to print that line of code right above my window there. So I'm going to say print. The answer is 6 times 7. Okay? Now when I run this, we should stop getting so big. It says the answer is 42. And what it did is it output the string the answer is, then it performed the math and output the result. Now, we can also write it without the comma. Let's see what happens when I remove the comma. Doesn't like it. But you can do this. You can, I think, is it the plus one in this one? Hold on, let me figure it out.
Mm-hmm.
Yeah, now I have to convert it to a string. I put a plus there, which is actually a string concatenation. See the plus I put right there? I got rid of the comma and put a plus. So string concatenation means take these two strings and put them together. Well, I took this string, looked over and said, that ain't a string.
You can cast it.
Yeah, we can cast it, which we're going to do. So it's telling me is, hey, it must be a string, not an int. So what we can do, we can actually take this result and say str, and now we're saying that is now a string. So if I run it, now I get the same result, but you notice the space is missing. So if you want that, then you'd have to add the space here. So my question for you is, what's easier? Using the comma or doing all this other stuff? Using the comma, but you need this sometimes. Depending on what you're doing, sometimes you might want this. Okay? Maybe you don't want the comma, and so we'll play with more of that. But normally, just writing with a comma like they have is totally sufficient. So each value is passed to the function, so it passed the string, and it passed the integer, and then an output both within that space in between. Pretty simple thing to do. Okay, by default, the print function starts a new line. So if we did print hello, print world, you would get hello and world on separate lines. Okay? Nothing real special there. Okay. Our second program, and I don't want to walk through this, but we'll talk. We're not going to write it. So we can print 7. We can print hello world. We can print my favorite numbers are. So what's this one going to do? Let's see what it does. It's going to print my favorite number are. That's not even good English. It's like, you can't say that. My favorite number are 7 and 13. You see how that's going to do it? And it'll actually have spaces between them. Why did they do that? That's bad. Then we could also print the by a space. So we can do all kinds of different things with print. It's really basic. Okay. You need to talk about errors. Now, the textbook, by the way, goes really great detail on some of this stuff. We're barely touching on some of it. You have compile time errors, also known as syntax errors. Maybe you spelt print wrong. You left off a quote or something like that. You didn't indent correctly. Spelling, capitalization, ordering of statements, matching prints, all those are syntax errors. It won't even run. You try to write it, it's like, just like I did, earlier, come up with that red, hey, error on this line. That would be a compile time or a run. Oh, it's not really run time. It's compile or when it's processing it. Okay. When you do this, sometimes you'll have a lot of errors. Not always, but sometimes you do. Always try to fix the first one first. Because sometimes the first one will cause a bunch of other errors that aren't technically errors. Okay. Runtime could be logic errors. It syntactically was correct. I mean, you had the right parentheses, you spelled everything right, but you didn't do the right thing. You screwed up on something you wanted to do. The program may die, but it looked right, but when I tried to run it, it didn't quite work. Okay? Or has unintended results.
This is missing a comma.
All right, syntax errors. So it says miscapitalized word, print is a lowercase, so we can fix that. Okay? Or we leave out the quotes. Or we have unmatched quotes, or no other bracket. I mean, you're going to make all these errors. Promise you are. I make them all the time too.
It's the small errors that it's hard to fix because you can't find it.
Right, it is. Okay. Type example above the wing shell. What errors are generated? I mean, you can walk through that if you want, but we've already actually done quite a few of those. Okay, they're pretty basic. Now let's talk about logic errors. Divide by 0. Okay, I have an issue with divide by 0. You know how that's one thing you just can't do? I've talked to math people. I watched tons of YouTube videos, and no one has fully convinced me that we can't divide by 0. I think it's fake. I think we can. They just tell the programs we can't. But it's okay. Misspell the output.
Wait, you think that we can divide by?
I know we can't, but I still. No one has fully explained it to me to the point where I totally agree with you. I'm sorry. It's just
imagine it. Never mind. Go ahead.
Yeah, I know. Because I literally went over and talked to a math professor. I know we can't do it, but no one. Some things in life that like,
it was only like dividing by nothing. That's the problem.
Well,
there is no
0 is something.
It's like it's the opposite of different.
Yes, it's irrational.
I literally watched hours of videos on this, and I understand it all, but it's like, I don't like it.
I understand.
I'm just not happy with it.
When I first learned it, I just hated it.
I didn't learn that.
Okay, maybe here, it was funny because I'm going on a trip tomorrow. By the way, don't come see me tomorrow. I'll be in Tulsa all day. But my secretary did the travel. And instead of going to the Oklahoma Truckers Association, I'm going to the Oklahoma Tuckers Association. I mean, she just left all the off. Obviously, I can still go on my trip. But can you imagine if that was an actual program and it tried to map? Oh, there is no such thing called the Tuckers Association, and that would suck. So, Or if you get to output something, a lot of times that happens. You're, oh, I forgot to do this, or I forgot, different things. Okay. Sometimes they'll compile and run, but they won't give you the expected output or do whatever. Okay. Easy enough there. All right. See, the whole, like Superman, I understand you cannot step on Superman's cape. You don't do that. I still. All right. So, everybody kind of okay here? Okay, I'm going to end this. Actually, I'm not going to end the slides. We're going to go back here. Way back. Where was that at? Where's the darn car? Oh, no.
Yeah,
Is it behind the car?
just passed it. Okay.
All right. We're going to do this. We're going to write a Python program to do this. Sound good? Okay. We'll do it together. We're going to calculate the total cost of each car. The total cost, to calculate total cost of each, for each year, we need to calculate the operating cost. The operating cost depends on the annual fuel cost. Okay? Annual fuel cost is price per gallon. What did it say our price per gallon was? $4 a gallon, wasn't it?
Mhm.
So I'm going to say price equals 4.00. We good? Everyone with me? Now, I like running my programs very frequently. That way, if I screw it up, so I'm going to run that, and sure enough, I ran this, I restarted my shell, and what output did I get? Nothing. So is that an error? No, it's not an error. Okay. Now, to do this correctly, I should really be up here, and I could say current price for gas. Technically, that's a bad thing to do because gas prices change. I should probably prompt someone for what's the current, but we're not going to do that. Okay. So now we know the gas. Where are we at? So I can minimize that one maybe. All right. Price per gallon times annual fuel consumed. Okay. So we need to calculate how much fuel is consumed. So it says annual fuel consumed is the annual miles driven. So how many? I think it was 15,000 miles, wasn't it? So miles driven equals 15,000. Everyone with me? Now, I got two different types of variables here. What type is the first one? Unsigned, but a double, a float,
Double.
something like that. Because that's what they're normally defined as. It's unsigned, right? Now, miles driven, now what would that one be? That's a decimal, or an integer, basically. Decimal integer. Okay. This one has decimal places, this one does not. Okay. So now we have that. So now we need fuel efficiency. Now, I'm writing my variables differently. I like to start them with a lowercase. Then the first letter of every subsequent word, I uppercase it. It's just something I do. It's a lot of language. I mean, it really doesn't matter. But it's just one of those things. If you stick to a certain way of doing it, a coding convention, it's really, that's the way Java does it. That's the way a lot of Python does it. Okay. Fuel efficiency of my car, gas and electric combined, is currently at 106 miles per gallon. Okay. So I have that. And we're going to do this for my car. So total cost, now I need to come up with the purchase price. I bought my car for $34,000. Okay. What sucks is it really thinks I need gas the whole time. So that's going to suck. Oh, that's good. So the total cost, so now we need to calculate the operating cost. All right. So we need to come up with the operating cost. So the operating cost depends on annual fuel cost. Annual fuel cost is price per gallon times annual fuel consumed. Annual fuel consumed is annual driven. So we need to calculate annual fuel consumed, correct? So I'm going to go and fuel consumed. Annual fuel consumed is miles driven divided by fuel efficiency. E-F-F-I-C-I-E-N-C-Y. Okay. Is everybody with me so far? Nothing special there. So that is our annual fuel consumed So annual fuel cost is price per gallon. So now we need to come up with annual fuel cost equals price times and fuel consumed. Am I correct? Now I'm going to put a comment down here on operating costs. Now I'm going to run this, make sure I didn't screw something up yet. So, did it work correctly? Anyone see? Yeah, it did exactly what I told it to do, and it ran fine. Okay, so it's trying to get. So now we need to figure out the operating cost. What did they say for operating cost depends on the annual fuel cost. So the operating cost depends on the fuel cost. So the operating cost is really what it costs me to drive it. So operating cost is really the annual fuel cost. Okay. Now I probably would have not had two separate variables there, but it's okay. So now we need total cost is purchase price plus operating cost. So now we need total cost equals price, wait, that's fuel price. I need purchase price plus operating cost. Okay. Everyone with me? If I run this,
Operating cost something.
oh, yeah, what was operating cost? Oh, I forgot the equal sign. So what was that error? Invalid syntax. What is it telling me is, hey, you're saying operating cost and your fuel cost. I'm not telling you what to do with it. So I missed the equal sign.
Is there a reason you did that, or?
I could have, I didn't have to make two separate variables.
Okay.
Yeah, I didn't. I just didn't realize it until after I made it. Yeah, because it's very valid point. It's stupid. I really don't need the annual fuel cost variable. I really could have put operating cost right here. It would have saved me a variable declaration. But that's okay. I already wrote it. So. And you know, movie Apollo 13 with Tom Hanks, y'all seen that? Okay. That movie is really good in one aspect. They show you how much limited power they had to start the Apollo 13 module. And they're really limited on what they can do. Nowadays with our computers, we're not limited anymore. So really, this is not a good thing to do because I actually used up memory storing that other variable. So now it should run. So now we're going to output print total cost. Well, we didn't figure out how many years yet, did we? Did we check? We didn't do years yet.
No.
So this is for 1 year, isn't it?
Yeah. And the
Okay.
ultimate was
That's the
10.
total cost.
Okay, that's the total cost of the car and the operating cost for 1 year. Okay, but what if we want to know the operating cost for 10 years? Obviously, I'm not going to purchase the car every 10 years. So what part has to be changed? So operating cost. So what we can do is we can say operating cost times 10. Make sense? I could have done it up here as well. So I took the operating cost times 10 because the purchase price isn't going to change. I only purchase it one time. I'm going to operate it. Now what's it cost to run my car? Okay, $39,660. We're going to figure out which car is actually cheaper. $39,660. Okay, that's my car. Now we're going to do my wife's car. Okay, have we got that working?
I got a different variable.
Different variable name or different result?
Different result. Yeah, I got a different result as well.
Am I wrong or did anyone get my result?
Yes.
I got it.
I'm not sure what I did differently.
Okay, you guys got the same stuff up here? 4, 1,500, 106, and 34,000. 15,000, 34,000. Probably off by a 0 or something.
Miles per I've got it. Yeah.
Got it?
Yeah. I put cost instead of concern.
All right, what I'm going to do now is I'm going to leave gas the same, leave miles driven the same. Now the efficiency. Now we're going to put in my wife's car. She gets, let's say, 45. Yeah. And I'm going to put a comment there so I can leave mine in there so I know. Now her purchase price was probably 19, we'll just go 19,000. So what I did was I changed the fuel efficiency, and I also changed the purchase. Here's a little more than 19. It was close. So, haven't run it yet. Which car should we be driving, or should I buy? Here we go. Remember, 39,660. Ah, darn it. 32.
What a steal.
So basically, I'm wasting what?
$7,000.
But there's always buts involved. My electricity is free. Sorry, solar panels. My gas is free. So my cost is actually up 0. Okay? So I have no cost for gas. So now let's put my numbers back in. Now let's see. 34,000. I'm still above. That sucks. Oh, forgot one thing. You need one more variable. Coolness factor.
You have to add in how much your batteries are going to cost to replace.
150,000 miles. Okay. Coolness factor of my car is 500,000.
Then you're going to divide that by the total cost.
Now we're going to, we're going to divide that. Yeah, we're going to divide the total. You can divide the price. So the purchase price is going to be, look at my car's going to win. That divided by coolness. I bet my car's cheaper now.
Should be.
My car's cost me 6.5 cents.
Every
I
10
win.
years-
See,
every
how that
10
works?
years.
So her car, she gets, we'll give her a 5,000 coolness factor. Put 46 and put 19. Hers cost her $3. I win. But you see how easy it is to modify these things? I mean, it's super duper simple to do. Okay. Without this program, could we have done this? But yeah, it would have been a pain in the butt. We would have, I mean, here we could literally change stuff so easily. Okay. Still think those numbers are wrong. My car's cheaper. I don't care. Why is it driving me crazy now? Because even at free gas and electricity, I'm still.
It's the car price.
What?
It's the car price.
Yeah, it is. And really, 15,000 is not that many miles. Yeah, it's definitely the car price. It's what? 15,000 more. But I don't know. We'll see. I'm going to buy a new one soon. So that'll even be more money. But. All right. Any questions on this? Everybody happy? Everybody figure out how to do that? Now,
What card you get?
I got an assignment for you guys for this week. Okay, go add it real quick.
Oh,
And find out where to add it. Hold on. Okay. Under here, I'm going to add another assignment. And I'm going to call this one Get Python Working. Okay. Actually, and how are you gonna, I need to add, this is an assignment. Somewhere I need to tell it to allow you to upload it. File upload, okay, we're doing good, we got that. Okay, it's available from tomorrow. That way you can't upload it today.
Put it today, please.
No, then you can do it right now. I want the whole point. I want to make sure you can do it at home. I'm giving you all the way to the next week. You really need to get your compilers working at home. That's the whole point of this. Okay? Everybody understand why? So if you just upload this, how do I know you even tried it at home? Okay. What I want is some proof you got Python working. Python. Oh, yeah. Now,
Of course I have it.
write something, run it, and send me a screenshot. All I need.
Send me a screenshot.
Write something, run it, send screenshot. Okay, that's all you gotta do. Good enough? I just really want you guys to get it working, because as this is gonna go a lot faster than the other stuff. And I think maybe it's there. I'm gonna add it under module 1. And this is the first time I've added one like this. That'll be for week 1. We're going to add an assignment called Get Python Working, and it should be right there. Upload. It's on week 1. Oh, and I need to edit. I need to make it due. That's not where I do it. I got to change the due date up.
It's there.
Okay, to make it due, we meet on Monday. Hold on, where's
Email it.
edit? Now, once you upload it in here. There it is. And it's due. Where's the due? Okay, it's due Monday the 27th at 12, no, 11, that's not 11, 11:30 a.m. And it's due before class, so we can't run into class real quick and do it. Okay.
No.
Good, sound good? Everybody see how that's gonna be done?
Yep.
All right. I don't care what it is. I don't care if it's hello world. I don't care if it's what we just worked on. Just get something, get it working, or else you're going to do these other programs and you're going to have issues. And... Okay, sound good?
Yep.
All right, we are done for today. And I just got to figure out how to get out of the meeting. All right. All right, you're free to go.